All right, class. So this is going to be our last section for our unit 10. This is going to be about the volume of solids. And I'll give you a second to take those notes down. And so with this new, I guess, kind of section, right? I think we've heard of volume before and whatnot, but this is really a new section. But with volume, it is going to basically just be like how much space are you actually like taking up, really? Right. So like how much is a box worth, how much is a cylinder worth, and all that stuff. Okay. And so for our first example here, a couple things, right? We want to make sure that we first know the equation for our volume. Trying to see what's going on here. So sorry. Interesting. Let's see. Oh, that would be why it's working. I didn't plug in the connection. There we go. Okay, so now it should. There it goes. Okay, so whenever we're going to do any kind of volume, we need to make sure that we have the correct equation. So for the prisms and the cylinders, we have this equation here, where again, if you look back at the previous notes, the capital B is the area of the base, and H is the height of the solid. Very important, the solid. Okay, and you'll see that in a little bit. Actually, one quick other thing, it should be centimeters cubed. Okay, so like not this right there, not that, centimeters cubed. But if I look at these two problems, I'll look at the left one first, and I very clearly can see a triangle. Okay, I see a triangle right here, and I see another triangle right there. Okay, so our base is a triangle. Okay. Now, the way that I've been able to explain the height of the solid is basically taking your two bases, or your one base, right, depending on what the shape is. Take the two bases and find the distance between the two bases. So right here, this distance of 2 centimeters is going to be the height of the solid. Okay. So kind of keep that in the back of your mind. Well, if I have the base of a triangle as part of my prism here, then I know that the area, capital B, equals A, or B is the base area, the area of the base, A is the area, and then I'm looking for a triangle, so the area is going to be 1/2 base times height. Be careful here, it's not the height of the prism, it is the height of the triangle. Okay, so just kind of keep that in the back of your mind. This is the height of the triangle and not the height of the solid. And so we know that B equals A and A equals 1/2 times base times height. And looking back at my equation for volume, it just says capital B times H. I'm going to put this all in for my capital V. So V equals 1/2 times base times height. Remember height of the triangle times the height of the prism. We'll call H. Okay, I've not done any math. I've just replaced what my capital B is with the area of the triangle. Now I'm going to plug in some stuff. I'm going to get 1/2. My base is 3. My height of the triangle is 4 times the height of 2 centimeters. And what I get as a result is going to be 12 centimeters cubed. And make sure that you have the cube there. Okay. The cylinder is going to be very similar. The nice thing is that we know that the base is going to be circle. because any cylinder is going to have the base of a circle. And we already know what the area of the circle is. We know capital B is going to equal A, the area of the circle, which the area of the circle equals IR squared. So we'll just do the same thing that we did in the previous problem, replace for volume. Volume equals I r squared times height. Luckily, we don't have any confusion with our h's here. So replace the values. Pi times my radius seems to be 9 squared, times my 6 for my height. Therefore, my volume is going to be 1526.813 feet cubed. Okay. I hope that is easy enough to understand. If not, of course, ask me some questions during class at an appropriate time or during a tutorial. That will all be fine and dandy. Now for these problems, go ahead and try them on your own first to see how far you can get, and come back whenever you feel like you have either the correct answer or you need some help, some guidance, and whatnot. All right, come on back. We look at this problem. We know that the base is a triangle. We have a triangular base. Now with this triangle base, we know that we're going to have an area of the base to be equal to 1/2 base times height of the triangle. And so we'll do the same thing that we did in the last problem, 1/2 base times height of the triangle times the height of the prism. Again, this is where you want to identify where are your bases. So here's my base. And here's my other base in the background here. And we know therefore that the difference, or the distance between the two of them is going to be this value. That's going to be our height of the prism. Okay, so make sure that you know those key differences. Otherwise, it's going to just be really hard for you. Okay. And, in actuality, really, like, it's all multiplication, so it doesn't really matter what order it is. But as far as, knowing the difference between the height of a triangle and the height of a solid, I think there's a very big difference between the two of them. So make sure that you understand what is what. Okay, we'll plug in 1/2 base is 5 times the height of 8 times the height of the prism to be 3. And I actually do have the answer already made out for us. It's going to be 60 centimeters cubed. This other problem, again, the exact same thing. I'm actually going to skip to this step right here, right? So not doing the whole thing. We know we have a base of a circle. And so that volume is going to equal that pi r squared times the height. Volume is pi times 5 squared times 9.1. And my answer is going to be 714.712 meters cubed. Okay. Now on mine, it might be rounded a little bit differently. It just kind of depends. But it's not going to be a huge difference in significance. So don't worry a whole lot if you get a slightly different answer by literal thousands. Okay. Okay. Next one, we have our volume of the pyramids and the cones. Okay, it's very similar to our prisms and our cylinders. They're all quite similar, actually. The key difference with the volume of the pyramid and the cone is that it's going to be 1/3 of the prism or the cylinder. Okay, it's going to be 1/3. I'm not entirely quite sure where the 1/3 comes from. Someone way more intelligent than I am, who had a lot more time on their hands, definitely figured this out more than I could. So, blame them. But yeah, so a lot of it is pretty much the same, just now we're multiplying a 1/3. And so if we look at this problem, we have a triangular pyramid, right? We know this is a triangular pyramid because it's a triangle as the base, and it has the pointed top up here. Okay, so that has got to be our base. So we write that down. Definitely a good idea. Anytime you're doing any kinds of problems like these. Angle. Okay. I'm going to skip ahead a little bit. We know we have the 1/3. We know the area of a triangle is going to be 1/2 base times the height of the triangle. And then we're going to multiply the height of the figure, the 3D figure. And then we're going to plug in all of these different pieces. So that 1/2, we have a base of a triangle to be, make sure I got it right. Oh, I'm going in the wrong direction. Oopsies. Sorry, I'm just looking at my notes. We're gonna have 1/3, 1/2. The base is gonna be 4. The height is gonna be 6 times the height of the pyramid itself, which is 9. We are going to get an answer of a volume to be 36 meters cubed. Okay. Next one, we have a cone here. So we know we have a circular base, circle base. We're going to skip ahead, right? We already know the area of a circle to be pi r squared. And then we're just going to be multiplying the height. Oops, hit that 1/3 in front. And then we're going to plug in. So 1/3 times pi, our radius is going to be 10 squared times the height of 13. And we are going to get some value that is 1361.356 millimeters cubed. Okay. And that is it for our cones and pyramids here, at least for right now. Go ahead and try these ones on your own. Be careful though, make sure you're paying attention to what the base is. Welcome back. Let's look at these problems here. We have a pyramid. Now, in particular, we have a 4-sided base for our pyramid. But because all 4 bases are congruent to each other, we know that our base is a square. Okay. And just because we didn't have a triangle or we didn't have any squares in the last couple of problems, we're going to clarify what the area of the square is. So capital B times A, not times A, but equals to A, equals A, which, you know, the square, it depends a lot who you ask, but it could be, you know, your length times your width. It could also be your base times the height square, right? Again, just making sure that we're not confused on that. It could also just be S squared, where S is the side length, right? Whichever way is better for you to understand, I would use that. But I find saying S squared is easiest, but I also know that base times height is going to be on your reference sheet. So I'm going to use base times height. Okay. So for my volume, I have that 1/3. I'm going to multiply the area of my base, which is a square, with that base times height. And I'm going to multiply by a height, and this height is of the pyramid itself. Now I'm going to replace all those values. 1/3 times the base, which is 4, times my other base, which is 4, or sorry, times my height of the square, which is 4, times the height of my pyramid, 2.4. And we are going to get our answer right here. So again, you have to be really careful with the bases. Okay, they're going to have different bases depending on what, or different equations for the bases depending on what the base actually is. So again, notice we have base times height for a square in this problem, but in the previous problems, we've had 1/2 base times height of the triangle. So just make sure that you know which one to do. Next problem here, we have a cone. We have a circle base. And again, we've done these a lot, so I don't think we really need to go full in depth and whatnot. We'll do our 1/3 pi r squared times our height. Our volume is going to equal 1/3 pi, my radius is 10 squared times 8.4, and my answer is going to be 879.645 meters cubed. Okay, do not forget your units. It's always going to be cubed. Do not forget your units. Okay. And then the last object that we're going to talk about is going to be the sphere. Okay, you get the notes here. But something to notice here is that we actually only have one variable. Okay, one variable, and that's going to be our radius. So as long as we have a radius, we can find anything or any volume of a sphere, which is really nice because in this first example, we're already given our radius. So V equals 4/3 pi times our radius 4.5 cubed. And therefore, we can just plug that straight into a calculator and we get the value for volume to be equal to 381.703. That is going to be in inches cubed. Okay. Now for this problem, go ahead and try it on your own first, but we have seen this problem before. And then welcome back, right? We know that we have the diameter, right? Because you go from one end of the circle, or in this case, the sphere, to the other end of the sphere, going through the center. So because we had that, we know this is diameter. So D equals 3, but we don't want diameter, we want radius. We just divide that by 2, we get 3/2, which is equal to 1.5. Okay, whichever way you prefer it. But you're going to take this this volume here, 4/3 times pi times the radius of 1.5 cubed, and you are going to get a value of 14.137 feet cubed. And that is it. That is all that we're going to do with volume. You're not going to have volume on this next quiz that's coming up. However, you will probably have volume on the next assessment, the next summative exam that we're going to have later on. Okay, so just keep that in the back of your mind whenever you're studying, that this is still important, even though we're so close to the end of the school year. It is still important to make sure that you are participating and doing your homework and doing all the problems, all the practice problems you can, asking all the questions you can, and whatnot. But there's nothing else I can tell you from here on. But go ahead and enjoy the rest of your day, and do something for yourself. But make sure you are still studying for those exams that are coming up. Okay. Alrighty, I'll see you later. Bye-bye.